Okay, this is a continuation of dealing with sampling distributions when the distribution of population data or the parent population is not normally distributed. So here's another example. Suppose the mean number of college credits that a student has taken by the time he or she takes an Intro to Statistics class is 64 credits and the standard deviation is 31. This distribution is right skewed. Suppose a random sample of 100 students were surveyed concerning their internet usage. The sample of 100 would be considered large. What is the mean, the standard deviation, and the shape of the sampling distribution of the mean number of college credits that a student has taken by the time he or she takes an Intro to Stats class? So stop the recording, see if you can come up with the mean standard deviation of the shape of the sampling distribution. Okay, so here's the mean. So the mean of all possible means in our sampling distribution is equal to the mean of the original distribution, which is 64 credits. The standard deviation of the sampling distribution is the standard deviation of the original population divided by the square root of n, square root of our sample size. And so this one would be 31 divided by the square root of 100, and that would be 3.1. The shape of our sampling distribution, since our sample size is large, would be a normal bell-shaped distribution. Okay, let's go through an example of this with an applet. Okay, so say for instance, let's do this. Let us do something where we have a normal distribution. Say for instance, or excuse me, let's try this to where we have a skewed distribution, a right skewed distribution. Say for instance I take a sample of 5. Okay, each time I take a sample of 5. So here's a sample of 5 here, and then there's the mean. Okay, I take another sample of 5. Here's the mean. Okay, another sample of 5. Here's the mean. And I'll just keep on doing it here. If you notice here, it doesn't look too bad. It almost looks like a bell-shaped distribution, but there's a little bit of skewness to the right here. In fact, you can confirm that here by the mean being larger than the median. Okay, but if you take a look at this here, the mean is the same, whether it's the parent population or the sampling distribution. The mean is the same, and our standard deviation, if we were to take this number divided by the square root of 5, it would be close to the standard deviation, which is 2.79. Now let's convert this now where our sample size is equal to 25. So say for instance we take a sample of 25, okay, and then we get a mean here, and we take another sample of 25, and we get another mean, and then we just keep doing it here. And then as you notice here, we have something that looks very much like a bell-shaped distribution, okay? And if you notice here that the means are about the same here, as well as if you take this standard deviation here and divide it by the square root of 25, you will get 1.23, or about 1.23 as your standard deviation. But the shape of this distribution, because our sample size is large enough, is 25. Okay. Now, if you wanted to work with this, let me just go back a couple of slides here. You can take this applet here and play around with it as well too. You need to have Java updated, but you can use this to be able to check that for yourself as well. Okay. Now, the next thing I like to cover is sampling distributions. When the sampling distributions of the population data is normally, let me start that sentence again. We look at sampling distributions where the distribution of population data is normally distributed. Okay, so now what I'd like to do is let's talk about shape, center, and spread again of a sampling distribution. Now, given the fact that the original data is normally distributed, regardless of the sample size, the shape of the distribution of sample means is still going to be normal. Okay, it doesn't matter. I can have a sample size of 2, and the sampling distribution of sample means will still be normal. Okay, the center is the same like we've seen before. The mean of the population, if the mean of the population is mu, which is the true mean, then the mean of this distribution of sample means is also mu. These are equal. And the same thing with the spread of the sampling distribution. The standard deviation of the population is sigma. Then the standard deviation, which is our true population standard deviation, then the spread, then the standard deviation of the distribution of sample means is sigma divided by the square root of our sample size. So the standard deviation of the distribution of sample means would be smaller than the standard deviation of the population by a factor of the square root of n. As you can see here on this slide here, if this is the population distribution, okay, if we were to have, say, a sample size of 10, notice here that the center increases, but the spread of the distribution shrinks. And the shape of this is still a normal distribution. Okay, so what I'll do is that in the next video, I'll continue to cover the sampling distributions when the distribution population data is normally distributed.